Hi everyone, today we're going to work on this basic idea of average rate, and we're going to kind of make it a little more complex than our Algebra 1 version of it. So we find average rate. So what's the idea of average rate? Rate is how much something is changing, like a bank rate, your rate of how tall you grew over high school, right? That's a change. So what is our average change? That's another way we can say it. So if I give you a graph, and we see a parabola. Sometimes we lost, sometimes we gained, sometimes we lost, sometimes we gained. But overall, what is the rate? Now let's call this from A to B. So let's say this was money. Ka-ching, money. Did we make money or lose money overall? Let's ask that first question. Did we make money or did we lose money overall? From point A to point B, did we gain money or we lost money? So we can say we made money, right? We start off some value here. Let's call this like 10 million, right? And then we went to 5 million. So overall, we made money. Now, the rate says over that period, how much do we grow and at what speed? At what change? How do we change? And if we give ourselves a value, it's the rate is given by f of b minus f of a over b minus a. That is our rate. Now we call this average because at any one point, were we really exactly this speed? We lost some, we gained some. We gained a lot at the end just to barely squeeze out a win. But you could agree with me that overall, we have an average rate of growth. We were making money overall. And that's really what you want to see in your stock market portfolio. You want to see that overall, on the average rate, you are gaining money. Sure, some days are bad. Some days are going to be really good. But overall, it's going to give you a trend of how well you're doing. Right? And this overall rate is done by f of b minus f of a over b minus a. If you remember this equation, this is also the equation for slope. And slope is this idea of what is the rate of change. For a regular line, y is equal to mx plus b, y is equal to 3x plus 2. The rate here is considered the 3 here. How much am I growing? We start at 2, and every step I take, every move I make, I'm going 3 steps up for every 1 step over, 3 over 1. So when I look at a graph of a line, 1, 2, put a dot, the average rate is 1, 2, 3 over 1. So you can see my change is a positive change. I'm actually growing a lot. So let's go ahead and talk about a problem here. If I give you 2 points, what's the average rate of change? We'll see it's going to be 2 and 5 and 1 and 6. Okay, 2 and 5 and 1 and 6. And the graph is, here's my graph, whatever it may look like. But what is the average rate of change between, cause f of x? What's the average rate of change of f of x between 2 and 5? Okay, what's the average rate of change? Well, our formula is f of b minus f of a over b minus a. And this is a fancy way of saying your y2 minus y1. What's your y's? Subtract your y's over subtract your x's, which is another way of saying rise over run. Okay, this is slope. So what happens at the end? We have f of 5 minus f of 2, right? These are x values. This is my b and this is my a over 5 minus 2. Now we always say b minus a because if b is on the right side, see how b is on the right side? B is going to be bigger than my a value, so we're going to say right minus left. So we always end up with a positive number on the bottom. Now what is the value of f of 5? F at 5 is, we said, was number 6. F at 2 is the number 1 over 5 minus 2 is 5 minus 3. And our rate of change, or average growth, is 5 over 3. It's like slope, but this is on average, what did we grow? Now let me go ahead and show you what I mean again on average. Did we really grow exactly in this nice straight line here? No, we didn't. So overall, we grew by 5 over 3. And hopefully you would see that sometimes we're losing a little bit. Sometimes we're winning a lot. Sometimes we lost again. But remember, average means we take our highs and our lows and we balance them out to figure out where are we at now. Sometimes you make money, a lot of money, sometimes you make a little money, sometimes you lose money. But overall, hopefully you're going to be up. Now let's give you guys an equation to figure this out. If I say f of x is equal to x squared plus 4 and between -2 and 3. What's the average rate of change between these 2 points? And I could graph it, sure, right? But graphing always takes a little bit of time. But all we're saying it's f of b minus f of a over b minus a. This is the idea of what you're looking at the end result, look at your beginning result, and see how much we've grown over time. You guys might have little measuring sticks and little measuring posters along your wall at home. And it says 3 years old, 4 years old, 5 years old. And you can see how much you've grown over so many years. And so we just picked 2 dates. F of b, which is f at 3, minus f at -2 over 3 minus -2. Let's go ahead and plug these values in. F of 3 means I'm going to plug 3 in. 3 squared plus 4 over, sorry, minus, what am I with minus? Minus 3, oh, sorry, I used the wrong number. -2 squared plus 4 all over 3 minus -2. Now, if you notice what I did here, I just plugged in the function, plug that in. I just plugged that in. So all we're doing is plugging values to find the y value. What is the y value at -2? Well, the y value at -2 is -2 squared is 4 plus 4 is 8. See, that's going to be 8 for us. If I plug in 3, 3 squared is 9. 9 plus 4 is 13. 13 minus, we said it was going to be 2 times 2 is 4, 8 over negative is a positive over 5. This becomes 5 over 5. It's 1. Turns out I had a growth rate of 1 over 1 on average. On average, this graph grew and made money on a rate of 1 over 1. Is that really the value inside though? Well, let's go ahead and just graph it. I said I wasn't going to waste the time, but let's go ahead and draw 1, 2, 3, 4, put a dot. 2 steps over, 4 steps up, 1, 2, 3, 4. And we said this was going to be 8, right? That's 8. And then 1, 2, 3. And then we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. So the parabola, oops, looks something like this. We're taking specific points at -2 and 3. So this was going to be 13. So overall, we had a growth of 1 over 1. Rise over 1, 1 over 1, 1 over 1, 1 over 1, 1 over 1, right? And we were just called up. So overall, we're winning. Okay, so this is our general idea and what we're trying to do. And hopefully you don't find this hard, but when I say average rate, it is a change. How much am I changing? I'm changing at what rate? I'm changing at a rise over run. Okay, and it can be that simple, that plain. That's fine. Now, here is our next challenge. Okay, this is, I say it's a challenge because we're going to throw in a variable. And this next challenge is I'm not going to plug in a number. Well, I'm not going to plug in, I'm going to tell you what to plug in. Okay, so here's our example. We're going to say f of x is equal to that, say, 2x. Okay, and then I say, what is where x is between -4 and x is between -4 plus h, where h is not equal to 0. Now, what is h? H is this idea of a little bit of change. So instead of saying 2 different points, like what I did here, I said -2 and 3. Instead, I want to say x is -2 and h is 5. Why did I say h is 5? H is the difference between the two steps. 1, 2, 3, 4, 5. H is referring to the distance between your first point and your second point. It's a weird way of saying it, but it's a way we do in calculus because we're going to be able to cheat this method in our next lesson. Again, let me say this again. H is the distance from your first point onward. Your parents talk like this sometimes. Now here's an example. If you guys have a brother and sister, let's say your name is Nazareth and your brother name is Jose, because I have Jose in the class right now. Okay, let's say Nazareth is 10 years old and Jose is 12 years old. And your parents love Nazareth so much. They say Nazareth is 10 years old and Jose is 2 years older than Nazareth. You see how I said Nazareth's name again? I could have said Jose is 12. I could have said that, but instead I said Jose is 2 years older than Nazareth. And that's the idea of H. H is that number that I'm saying that's apart from my original value here. And that's what H is. It's just a way of telling you that second number without really explicitly pointing it out. So if we look here, my first number is -4. My second number is H away from -4. It's -4 plus a little bit of space. So let's go ahead and set this up again. To find the average distance, what's the average or average rate? What's the average rate of 2x? Well, let's go ahead and write it. So it's f of b minus f of a over b minus 2a. But my a and b values are all skewed. My a value here is -4, and my b value is -4 plus h. Exactly, that's what it is. It's -4 plus a little bit of something, that little bit of space, whatever that space is. The space is not 0, but it's just something, right? Maybe it's 2, maybe it's 3, maybe it's 4. It's a variable that we can manipulate and change. And that's why we do it, because I don't want to get you stuck that h has to be 5. H is just that space that I'm giving you. So we're going to rewrite this. Rewrite this, okay? F of b is f of -4 plus h minus f of -4 all over -4 plus h minus -4. Please take a look here that you are okay with this pattern. This is super confusing for a lot of people. They feel like, where did all these numbers come from? Well, f of b is my -4 plus h. F of a is my -4. So it's my new version versus my old version. You guys have an iPhone and you guys have the iPhone, what was it, like an iPhone 8 and an iPhone 8s? S is that little h, it's my just a little bit of difference. What's the difference? Nothing much. Maybe a bigger battery. Now from here, we're going to go ahead and plug it in. Plug in f. We said f is 2x. So fine. 2x minus 2x over -4 plus h minus -4. Now this really is the way what happened to the 2? Whoops, did I forget something? Oh, sorry, this over here is, so I messed up here. That is b minus a. I'm not sure why I wrote a 2 there. I'm sorry about that. If you guys can erase that, I'm not sure why there's a 2 here. Is b minus f of b minus f of a over b minus a. I'm sorry, I don't know why there's a 2 there. So we're going to go ahead and plug in my x's. We have special x's for these problems. It's going to be -4 plus h and then -4, right? Because this is our function at -4, which is 2 times -4. Okay, let's continue. We're going to distribute -8 plus 2h plus 8 over -4 plus h plus 4. We can simplify. We have 8 and 8. Hopefully you guys have 8 and 8. Those are going to cancel out. Our 4 and 4 are going to cancel out. And we're left with 2h over h. Lucky for us, look at what happens. What happens to those h's? And we're left with 2. Now, this seems like a really roundabout way, but let me ask you this question here. Does it look like that the average rate of change is going to be 2? Well, let's go back and look at our original problem. We said the original problem was y is equal to 2x. If I draw a graph and the slope is 1, 2 over 1, isn't the average rate of change 2 spaces? 1, 2 over 1, 1, 2 over 1, 1, 2 over 1. What happens is we just literally defined what the slope of this graph was. The slope at any 2 points. Now here's the crazy part. If h was 1 space away, isn't the slope so 2? What if h was 2 spaces away? The slope is still 2. What if the slope was what if the h was 3 spaces away? The slope is still 2. So we were able to generalize what would our slope be with an h value instead. Now let's do this problem with a parabola. Let's do this problem with a parabola. And what if I write y is equal to negative x squared? Remember, this can also be written as f of x. Okay. Now we're going to use the same idea. X is equal to 4. This is going to be positive 4 now, and x will be 4 plus h. So this is my start, and this is my bumped over version, my upgraded version. How far is h? Who knows, right? But we're going to generalize it. H is just some value separate from x. If x was, let me show you a number line here. If x was 4, h would be that many spaces away from 4. Okay, so h is this distance, so that's 4 plus h. Oops. H would tell me how far I'm away. And if h was 1, we'd be at 5. If h was 2, we'd be at 6. If h was 3, we'd be at 7. But if h was -1, we'd be at positive 3. We could go backwards too. Okay, so if I ask you find the slope, or if I find the average change, or average rate of change, let's use that word, average rate of change. In this case, we could also say this is the slope of the secant line. This is the slope of the secant line. A secant line is where 2 points meet. Okay, so let me just should go ahead and show you this graph right now. We have a graph with a parabola facing downward. And if we start at 4, 1, 2, 3, 4, that's going to be 4 squared is negative 16. So what happens if I go on my next step? Isn't that a pretty steep slope? What if I go on the next step after that? Wouldn't that be even more steep and even more steep, right? So the idea is the further I go, the slope is going to get worse and worse and worse. And I'm going to show you that's going to be the effect of the slope. Let's go and get started. We want to write the formula f of b minus f of a over b minus a. Please realize in calculus, we will use this idea of a slope so many times. This can be rewritten is f of x, 4 plus h minus f of 4 over 4 plus h minus 4. Okay. Now you have to do all, this is all algebra 2 work now. This is all algebra 2. The only pre-calculus, calculus work is me setting it up. Everything else is algebra 2. Plug in f. We said f was negative x squared, so negative 4 plus h squared minus a negative 4, 4. Because the function is negative 4, right? The function f was negative 4, sorry, was, oh darn it, I made a mistake. Sorry, I'm just talking too much. It's going to be negative x squared. That's my function, negative x squared. So it's going to be 4 squared, negative, sorry, rewrite it, negative 4 squared like that, sorry. Because it's going to be negative x squared all over 4 plus h minus 4. Seems like a lot of writing, but I'm just copying it over again. F is really x squared, so that's why I wrote x squared here. What's x? X is 4 plus h. Okay, for the top, let's go ahead and multiply it out. If you guys have to be okay with this, how do I square a binomial? You guys remember how to square a binomial? X plus 2 squared is square the front, square the back, and double the middle. X plus 3 squared is square the front, square the back, double the middle. X plus 6 squared is square the front, square the back, and double the middle. Okay, that's our rule. So here's our last moves. We're gonna go ahead and square this. It'll be negative. 4 is 16. Plus 4 plus 4 is 8. Plus h squared. Okay, and then that's gonna be 16. So plus 16. All over 4 minus 4 cancels out. H. We keep on going. Negative 16 minus 8h minus h squared plus 16. You'll see that these two cancel out over h. We're left with negative 8h minus h squared over h. We can divide h here. Let's go ahead and do it. Negative 8 minus, oh, let me write it out for you guys. You guys see the math. Factor out the h. Negative 8 minus h over h. Because I factored out the h. H is divided out. Our average rate of change is 8 minus h. Now, this is my slope. This is also considered my slope of my secant line. Okay, this could be considered the rate of change. Exactly all the same, different words for the same idea. Now, was this true? As h got bigger, 1, 2, 3, wouldn't that make this problem more negative? Right? If h was negative 1, oh, so h was 1, 8 minus 1 is negative 9. If h was 2 spaces away, we're at negative 10. If h was 3, we're at negative 11. So the farther I go along away, the more this becomes slopey. And that's really what you guys are going to practice today. You guys are going to create the slope equation using this odd way of writing 2 points, where the second point is just h away. And I'm not going to tell you what the h is. It's just going to be a variable that we're going to leave so that we can always find the different slopes for any value of h so many steps away. Okay. We're going to do one more example here, and then we'll call it a day. Here's our problem. It's going to look like a Sith Lord. It's going to be 3x squared plus 10x plus 15. That's my f of x. And my x is 4. And my second x is 4 plus. It's going to be 4 plus h, because we want it to be h steps away. Okay, again, remember, we could have put 2. This could be 4 and 6. This could be 4 and 7, 4 and 8. But the point is to not write a number. Keep it vague. Hey, what you doing this Friday? I'm busy. What you doing? Busy. Do you want to hang out this weekend? No, I'm busy. But what you doing? I'm busy. See, keep it vague. Don't tell them what you're doing. Just keep it vague. And that's our point. We're going to keep it vague. So our problem is f of b minus f of a over b minus a, which is f of the farther point minus f of our closer point. And sorry, we can write the b and a now. B is 4 plus h minus 4. Okay, so that's a setup. It's always the f of b minus a minus divided by b minus a. And it's always the second point minus the first point. Just make sure you keep the order. See, the order is, they're lined up. Okay, let me show you this right here. Look, they're lined up. These are lined up and these are lined up, right? They're both lined up. Now the hard part is plugging it in correctly without hating yourself. It's gonna be 3, 4 plus h squared, right? We're plugging in our f value now. Plus 10 times 4 plus h plus 15 minus 3 times 4 squared plus 10 times 4 plus 15 all over 4 plus h minus 4. So I just took my function and I just plugged in what my x is. Now, fortunately, it is a gigantic mess. But if you guys can get this now in calculus, your first semester is going to be super easy, at least the first quarter. all this work. Now the hard part now is this crazy mess of algebra in the front. This is going to be 16 plus 8h plus h squared. Okay, when we square it, square the front, square the back, double the middle. And we're going to multiply all that by 3. 3 times 16 is 48 plus 24h plus 3h squared. 10 times 4, 10 times h plus 40 plus 10h plus 15. Keep on going in the back. 4 times 4 is 16. 16 times 3 is 48. Negative 48 minus 40. Oh, I forgot the x. No, I don't need x. And then plus, those are minus the 15. All over, how many can't see that? All over h. Now, if you did it right, you're going to get rid of everything on top except for only values with h left over. So let's look for what we're going to get rid of. 48, negative 40, going to cancel out. Perfect. 40, 40, going to cancel out. Perfect. 15, 15. Oh, man. Check it out. Please, everyone, look what's left over. We have 24h has an h. 3h squared has an h. 10 has an h. See how they all have h's left over? That's what you better get if you did this right. So I'm going to rewrite 24h plus 3h squared plus 10h. Hey, I can combine 10h and 24, right? They combine out to become, I'm just going to write it here, 34h plus 3h squared over h. Folks, we can divide out the h's. So you have an h, you have an h, everyone has an h. We can divide it 3, 4 plus 3h. This is our answer. The slope is changing at this crazy rate, starting at 34 and changing by h times 3 every single step we take away from h from x is 4. And that's it. That's our slope equation. Now, if h is farther away, that problem will change. Our slope will change because we built in a little bit of variable to help change those things.